I'm Andrés. I work at Neo4j as the GraphQL team. I will tell you a bit about what we do. But the meat of the whole thing is going to be how we use subscriptions, GraphQL subscriptions, with our library. So first of all, lovely picture, a picture that I like a bit more than the other one. Okay, there is my Twitter, email, if you want to contact me, message me about anything, who I am. Well, you all know. Before all, because this is an interactive session, who here who have ever used Neo4j? Oh, well, more than I expected. I am not going to change this right now, so you're going to have to go on with the introduction. The rest of you, well, who has not heard of Neo4j, doesn't know anything about Neo4j, what it is? Don't be shy, okay, that's good. Well, surprisingly, a lot of people know Neo4j now. Well, so, what is Neo4j? Most of you already heard of that. Basically, it's a database that lets us store our data as a graph. So, here we're not talking about columns or tables or big JSON or anything. Your data is not only represented as a graph, it's also modeled as a graph, all the way to the database, which is really cool. Here in this small example, you can see a few films with the actors and directors and stuff. It's, I think, a lovely picture to show what it is really Neo4j. Also, I'm not going to tell you a lot of this because you're not for this here, but this is how you communicate with Neo4j using the language Cypher, which is quite similar to SQL, so probably most of you kind of know what's going on here. The most interesting bit, sorry about that, the most interesting bit here is actually this kind of ASCII thing that lets us go from one node, in this case a person, to another node, and we'll be going through the relationship. I'm telling you this because that will come in handy for GraphQL later. So, this is a simple example of a Cypher query. I hope everyone can hear me well. If not, just tell me. So, we have a graph database, which is lovely, and we have GraphQL, which has graph in the name. So, graph query language and a graph database. Someone who was probably a genius said, well, you know what? Oh, yeah, it's completely broken, but let's try to do Neo4j GraphQL, where I work at, the official GraphQL library for Neo4j. And what does this library do? Well, other than really good for memes, it basically sits between GraphQL client, any client that you use, or even if you just go with HTTP request, and Neo4j database here, and in the middle sits with your server the GraphQL API, translating from a GraphQL query to Cypher. As we said, Cypher lets us traverse the database in a graphic way, which is how GraphQL works. So the translation is actually quite easy, definitely easier than with other non-graph databases. That makes quite sense, I hope. So how is this built? Well, when building a GraphQL server, probably most of you already have had this experience. You define your model, which is, I don't know, movie with a title of it, and then you need to start setting the query, the mutations, all the resolvers, and all that lovely stuff. But we said, nah, that's just what I say. How to make this email generation? That's where it's. That's why when you define with our library any type, any schema, that defines not only what kind of data you're going to send through GraphQL, it also actually defines how your data is going to look in the database. The magic of graph everywhere. And just by giving us that lovely statement of movies with titles, we already generate all of the basic root queries as well as many interesting extra queries there with the resolvers and everything. As well as the basic mutations that you would expect. That lets you do something like this. Just by setting up a library, you already have movies with a lot of filter, like released in 1999, get the title and say, oh, well, I need the actors as well, so let's just get them. All of this gets translated into a Cypher statement, and because we're working with graphs, that lets us translate all of this query into a single query to the database, into a single Cypher statement. The classic problem, N+1, You probably know about that. You get a nice, lovely GraphQL query, and it turns out that it's 100 SQL statements to the database, or whatever data you're using. There are a lot of ways to circumvent that, and we decided to just do a single statement. Because of the power of Cypher, we can go all the way nested statement in a physical way, which is great. This is an example of how the previous query, again, title, actors, and name, looks in the database, and this is what gets returned into your GraphQL API out of the box. I'm going a bit fast because we're a bit pressed on time, but I hope everyone kind of gets the rough idea. I'm not here to talk to you about the library, really. You can find a lot of documentation there. I'm here to talk to you about subscriptions. Yeah, this is the level I really, you're not going to expect anything better than this in this presentation. But if anyone is looking for, freelancing on fire, I'll try to find people for graphic design, just pay me, you have the so subscriptions. Subscriptions are a weird thing in GraphQL. They exist. And that's basically everything you know of subscriptions when you read the official documentation. They are quite useful, they're great, but it's often quite tricky to pull them off in an efficient way. But we're really at the money. Now, we want subscriptions. And because of that, on top of the queries and mutations that you've already seen, when you set up a library and say to the library, hey, I want to enable subscriptions as well, you also get this result of these queries that you can use this operation. Will be created, will be deleted, will be updated, any type of data that you have set, that is you filter and will return you the data in a subscription. I guess I don't have to explain it to you, but I will go really quickly how subscriptions work in GraphQL. Most of you probably know, but just for anyone who may not have ever used, you basically subscribe from the client to the server, and from then on, the server will keep sending you events. This is usually happening in WebSockets, but not necessarily. The standard doesn't really say how to send the messages, or even in what format, for that matter, which complicates things, but also gives you a lot of flexibility. This is roughly how it looks. You subscribe to, in this case, will be created, and you get the data, title, and you will start getting the data in the same format you asked for, which is how GraphQL is supposed to work, and you will keep getting data thrown at you. So, how subscriptions are built in Neo4j GraphQL? Because it's an interesting problem, and I thought I would like to share it with you. So, this diagram, which is probably what you would quickly draw, is how it works. So, nothing surprising here. We have an active subscription here between this random client and our server, and another random client performs a mutation. Our server performs a Cypher query to the database, does the mutation, it changes the database, it returns the response and everything. We're not focusing on that. And the server detects, oh, there's a mutation happening, and there's a subscription as well. Well, let's send the event, and it sends the event to any client. It's a simple concept. It has a few pitfalls, as we will see. We will zoom first into this step. This is quite trivial. This step is quite interesting, because this is an example of what our library does at the basic level. We have a mutation, we do this with input and the data, and it gets translated into this Cypher, which some of you will understand, some of you maybe have never seen something like this, but probably kind of infer what is happening. It's a fairly simple thing. But then you enable subscriptions, and this happens. On every mutation, we inject this extra thing in our Cypher, which looks a bit ugly, and it is, but it also lets us do a little bit of magic with Cypher, which is generating a new variable called meta, in which we inject this JSON. This includes all the data of the entity that has been mutated, and we return that as well as the data from the request. The data from the request goes to the original person who did the mutation, and the extra metadata stays in the server to be used to trigger the subscriptions. Sorry about that. What this means is that even with subscription enables, the M+1 problem is still solved. We're still doing a single request to the server, not store request, and we're solving all the subscriptions in the server directly. This means that you can have 20 subscriptions. You will be answering them with a single let's go to the database, which is lovely for performance. But then something happens. Some pesky PM, again is there. Hello, how are you? Some pesky PM tells you that this needs to work with multiple servers. And you start saying, oh well, this is lovely because now it happens that I have a subscription in our second server, and the invitation goes to the first one through the gods of, oh my god, through the gods of random requests being sent to each server. But we have something missing here, which is, okay, if this happened in this server, and we know we have a subscription here, how do we send that mutation data to the other server? There are several ways of solving this. One of them, which probably some of you already are imagining it, is this. Hey, instead of just sending the mutations back to your subscriptions in the server, we send events to a broker. The broker has a connection with all of the active servers. It will broadcast the signal. This broker could be anything, NGP, Redis, Kafka, whatever. And then every server will know that, oh, something happened. I should trigger the subscriptions. And you may be asking, well, this is lovely, but this setup is just a mess. It's not easy to use. Well, actually, with the library, it's super easy, barely any inconvenience. Oh, well, yes, I have a parrot as well. Sorry, I forgot about the parrot, but it's lovely, take pictures. It's actually super easy, very inconvenience. You just set up a plugin, in this case. I will go over the plugins in a moment. You just tell the library, hey, I want to use subscriptions connected to an AMQP server. Then we load the library, Neo4j GraphQL, just load the type definitions, GraphQL type definitions, pass the Neo4j driver, and we say, oh, well, I want to use this plugin. This is actually everything you need to set up the whole thing. Well, obviously you can have private key or any NTT server, but just that from a code perspective, you already have subscription working with all of the operations that you've seen, and the M+1 problem solved. Lovely. Currently, we only have this plugin, actually, but the whole system luckily is built for big customers, so it's really easy to build your own plugin with whatever service you need. The instructions are in the documentation as well, and I even have a demo, an example of writing a plugin with Redis, which is roughly, I don't know, 30 lines of code. And this is roughly everything you need for a somewhat production-ready service. Sorry, that was a spoiler. Although, mind you, the subscription is still a beta. It works really nice, as you will see in the demo, but just so you know. And regarding the demo, well, who here knows what this is? Okay, there's people in the Neo4j, fine. So this is Reddit Place, in case you didn't know. This was a canvas thing that Reddit did, where basically everyone could draw a single pixel on the canvas, and it's like a form of collaborative art. So for the demo, we thought, well, subscriptions, that sounds like a lovely way, a lovely application as a demo. So we built our own Neo place. You can use the link there, or the QR code. Don't worry, it will stay there. Please go there. I really hope it's working, because I haven't checked that. But we'll check in a moment. Oh, yes. Things are happening. Please don't do anything not wholesome. Thank you. There's no limit in this demo. So, how is this built? Because, well, it's a lovely thing, and it's actually going real time, so you can see it. And this is built, actually really easy. The example is all in the GitHub page. We have a database, a Neo4j database, obviously. A simple API that lets you draw pixels and get the pixels. A subscription setup as you saw with any pixel that has changed, we will get that. an Apollo server doing all the backbone of GraphQL server. And basically, all of that setup, when it comes to code, is all deployed in Google App Engine, so it scales automatically. The RabbitMQ, we're using a lovely cloud AMQP service that lets us use free RabbitMQ. The footprint of this and the overhead is really little, so it works really well, even at a reasonable scale. I think that's all. Thank you.